Good morning, welcome everybody. This will be my presentation about continuous media playback in Magnolia, which I will show right after this, what it means and why we decided to implement something like this. And if I have enough time after that, I will also talk about the way we handled our JavaScript, because we have a lot of websites running in Magnolia and we needed a central place to store all the JavaScript and to do some versioning, because otherwise it would become a big mess. A little thing about myself. My name is David. I work at VPRO for 2 years now as a front-end developer. This wonderful picture is a colleague of mine. He drew it after a meeting. I think it was a pretty boring meeting because he was drawing pictures. Apart from that, I like to take old crappy cars and drive them to the edge of the desert, like we did last year. And I went hiking in the mountains this year, which was also a wonderful experience. So, apart from being behind my laptop, I like to go outside, go cycling, hiking, stuff like that. Well, of course, there's work to do. I work in this wonderful building in Hilversum in the Netherlands, together with a team of about 20 people, which 3 of them are front-end developers, and we have some freelance front-end developers also, and a lot of back-end developers, designers, and together we're a well-organized team cranking out websites all the time. And the organization has been around since 1926, but it started doing stuff on the internet in the 90s, which was quite early for a broadcasting organization in the Netherlands. And we kind of had a head start, and up till now we maintain this position, being innovative in many ways. So 3 for 12 or 3 to 12 is a popular music website. Last year we did a complete redesign and rebuild of the website in Magnolia, and the concept for the site was to be a rich media experience, which is like it's just a term, but it's very important because there's loads and loads of music and videos on the website, and well, we would like the audience to be able to play that all the time and make it easy for them to play all the stuff. The thing that was important is that there was continuous playback of audio and video. So while browsing the site, you needed to be able to keep listening to the music you added to a queue. I believe the internet connection is down, but I will give it a try to illustrate what this site is all about. So doing a live demo is not always a good idea, but I would just like to try and show you what this site is about. This is the home page, and on the luisterpaal is the main section where all new albums are at. Usually we have pre-releases, so bands put up their albums here, and before they're actually for sale. Some of them are geo-blocked, so I'll just pick this one. So I can add some tracks here on the left side of the screen, and you'll see a queue, and well, there's actually a song playing here. I don't know if you can hear it, but just to make sure it's playing. So now if I want to read some news, the main part of the page refreshes, and as you see on the left side here, I can pick other songs as well. It just keeps on playing. So this was one of the requirements for the website, and it kind of cost us headaches because it's kind of a difficult thing to achieve. So now I'll try to explain how we did this in Magnolia. Well, the result I already showed you. So what we thought of was, as you just saw, it would be a good idea to just reload parts of the page instead of the entire document. And we came up with a structure like this. So on the left-hand side, you see the play queue. This is the part where all the media is added. So you can add your own items to the queue, video and audio. And on the right side, we created a container to load the content into. Now, if I wanted to load other pages from Magnolia into this container, I only want the content of these pages, so I don't want the entire document with the head and the title and everything else, and all the scripts and all the CSS. So I just need the content of the page. And how we achieved this was by using, accessing this URL through a different extension. So every time we call a page and we change the extension from HTML to Ajax, we manage to only receive the raw content of the page. So no head, no CSS, no scripts, just the basic content. How did we do this? Well, Magnolia has a concept called subtemplates, and which I believe is renamed to template variations, starting 4.5. As we haven't migrated yet, we are still referring to subtemplates. And what this does is that all the requests that end on .ajax are handled by a different template. So this template, this subtemplate, it includes the same free marker code, which is also in the default template, but it just doesn't have a head section. So how are we going to configure this in Magnolia? I hope you're able to read all this, but otherwise I will happily show you afterwards. The highlighted template is just the default news template with its own areas and configuration, its own dialog, whatever. And underneath it you can see another one, which is called 3v12 news, which is actually an extension of the default template. And the main difference is that it has a node called subtemplate and a node called Ajax. In this Ajax node, it represents, well, it kind of represents the extension we are using in the calls we are making. And all we do is we extend the default template and we override the template path. So we just make sure that a different piece of free marker is used instead of the default free marker. So, and then what happens if we make this request? This is the result. So if you go to our website afterwards and you'll change the URL from HTML, the extension of the extension of the URL from HTML to .ajax, you can see that you'll just get the raw content. So now when we had this figured out, we needed to do some stuff in the front end as well. So instead of just handling clicks on URLs the way the browser does by refreshing the entire document, we needed a way to catch the clicks in the document and prevent the default action. We then take the href out of the click, out of the event, and we have to do some checks. We have to see if this is something else than .html. For instance, if you add a PDF to a website, so you'll have just like an attachment, you'll want to load that. Whether it's an absolute URL, then it's probably going to a different website, and we just want to show that. We also have to check whether it's a media item. These are items throughout the website that can be added to the queue. Just video and audio items, so we don't want them to start the Ajax thing. After that, we have to check whether we are running in edit mode in Magnolia, because, well, obviously the editors they need to have basic access to the site and be able to edit their content. So after all of that is done, we rewrite the request, which is probably HTML, to a .ajax request. And we give that to an Ajax component, and that loads the content from the request. And the result which comes back is the raw result I showed you before, and this is loaded into the content container in the web page. I have the feeling that this might be a little complicated, but because of lack of time, I can't show you all the code. But if afterwards you're interested, or if you're online and you want to pop some questions, you'll be able to reach us. I'll show you my email address afterwards. So we still have the back button. Like the guy before me, William, he explained a lot about the History API. Thank you for that. It was a great introduction. but the lack in the history API, as William also stated, is that only modern browsers use it. So Internet Explorer doesn't really know how to handle this kind of thing. And there is a fallback construction which uses the hashbang URL. It's something I think it was introduced by Twitter, but might be somebody else. And it kind of works as everything behind the hash and the exclamation mark is like the content you're trying to load. So this works fine for IE, but what if somebody is browsing IE, copying the URL and pasting it into a website, then Google comes along and this doesn't resolve well. What Google did is they rewrite hashbang URLs using the escaped fragment parameter. And what this does is, for them it's a way to redirect to the content you're actually trying to show. So what we had to do is make sure that Magnolia has a proper way to handle these escape fragment parameters. So what we did, we went into the virtual URI mappings, a difficult word to pronounce, and what we did there is by using, what do you call these things? Regular expression, right? Is rewrite these URLs to make sure that the proper document is retrieved. So if for some reason Google would come across these hashbang URLs, they would be able to index the pages that we are trying to show them. So this was to me it feels like it's like a roller coaster ride through this technology, and as I said before, I would happily answer some questions afterwards. I don't know how many time I have left. How much? Halfway. So then I think I'll skip these questions and I'll continue to the next part, and we can do some questions afterwards if we have some time left, because I think this is also a very interesting thing to address too. You can reach me through Twitter or through email. So we do websites, quite a lot of them. This is just a small fraction of the amount of websites we're running. I think we have currently about 68 websites running inside one Magnolia instance, and we're also maintaining sites which are not yet in Magnolia, but we're planning to migrate into Magnolia. So, like I said, quite a lot of websites. And having a lot of websites means you have a lot of domains, and also even more JavaScript. So there is some shared functionality, but of course not all sites are equal. They all have their own specific functionality. And what it resulted in is that we had to do a lot of copy pasting of code. If a bug showed up somewhere, you were bound to find it in other sites as well, because we copy pasted a lot of code. So you had to apply these bug fixes to all other websites as well, which is a hassle. Well, the concept of don't repeat yourself didn't really apply. We tried to, but if you're copy pasting all the time, you just feel there's something not going well. And whenever we started a new project, we had to re-implement all the stuff again in another website, so you're still repeating yourself. And if you ever tried to reuse pieces of code, you got like a dependency spaghetti. There was no way of telling where what piece of code was coming from, what version you were loading, if there were versions at all. So we needed some way to solve this. So we came up with a wish list, which was actually a bit longer than the one I'm showing right now. But what we wanted was some way to have a centralized storage of all our JavaScript. And we wanted it on a dedicated subdomain. So just load all the JavaScripts from the same domain all the time. If a user goes to another website, it'll be nicely cached and everything. So that would be the best thing. And we really needed to work on the way we wrote JavaScript. So we needed to be more modular. And well, as I stated before, versioning is really important. We develop a lot, and we also add new features all the time, and it would be really difficult to have all sites keep track of the new functionality in the JavaScript. So we wanted to use versions just to say that this site can have this version of the module, and another site can have another version of a module. So, well, the name is it's quite obvious. It's the JavaScript server. I think we should come up with a proper name, because this is, well, it's really important to us. So we should be able to give it a proper name. It runs on js.vpro.nl. It's an Apache Tomcat installation. We have a lot of gifted Java developers walking around the office, and they were very happy to help us to provide us with an application platform. People might ask, why didn't you use Node.js or whatever? But it's just, this is plain, solid, proven technology, and it works fine up to now, so there's no problem. This is a Maven project. I don't know a lot about Maven, but if people want to know stuff, my colleague, yeah, he knows all about it. And of course, well, Maven has a versioning system which is proven technology as well, I think. So this is what we use to stack different versions of our JavaScript modules in the same application. And we started using RequireJS, which is a way of writing AMD modules and being able to load them whenever you need them. There's a lot of stuff. We implemented a way to serve files as JSON templates, and on top of that, we also added the gzip filter. So clients that are able to handle gzip, they will be offered gzip versions of the files. If I look at this now, this is quite a list. So, and we actually managed to pull it off. In the wild, in the outside world, this is on the left side. You see the JavaScript server, and it holds a certain amount of modules. There's actually a lot more than that, but this is just an example. And on the right side, you see the different some of the websites we run, and all of them hold the same, well, actually not the same file, but a file with the same name, which is like the starting point for the JavaScript implementation. And this is where we start loading all the modules we need for this specific website. As you can see, some of the modules are shared. And as I want to show you through this example, there's different versions of these modules. So the utis module can have different versions, and different websites can load different versions of this module. The way this is all organized on the server is a bit too complicated to dig into right now, but it works. I can assure you that. So when working with these modules, we decided to start using RequireJS. This is a wonderful way to I don't know if it's really a word, to modularize. Thank you. Your JavaScript, so you don't mess up the global scope. Everything is in nice, neat, compact packages with their own concern. And well, maybe if you're interested, you should just read the documentation for Require. It's also I think too much to dig into it right now, but it's really powerful stuff. And this small code example shows that the top two parts, the foo and the bar, are AMD modules. And the last piece of code shows an implementation on a website where you do a require call to these two modules. You attach a callback, and whenever these modules are loaded, you can start using them. It's really not too difficult to, if you see it like this, but it took us some time to get it right. But it's really powerful. So, the versioning. As I said before, the JavaScript server, it contains all the versions of all the files. And, well, I also said this before, we can grab certain versions of certain files from certain sites. We can configure this globally, so we can say website A has this version of all JavaScript modules. And this is the fact, actually, for a lot of sites. From the point we started implementing this, there was a certain version, and many of the websites are still depending on that version. But after that, we started building new websites, added some JavaScript functionality, and these new sites all have newer versions, and it goes quite well. So you can also you can configure it per site, or you can configure it per module. So if you do an implementation of the JavaScript in a website, you would say, okay, this is all the basic stuff, but I want the newest version of the image gallery, and you can, at a later point in the process, you can just add a version number and say, okay, I want the latest version of this JavaScript, of this JavaScript module. The JavaScript server path is configured in Magnolia. And this is very important because if you run a local Magnolia instance, you would want to have it talk to the local JavaScript server on your development environment. And of course, you can also, if you want to track some bugs, you can start up local Magnolia instance and then have it run against the production JavaScript server. So we are really flexible in where we pull the code from, and this is really useful for bug fixing. And of course, if you work locally, you always get the latest versions from the JavaScript server. And I believe this is also a Maven thing or an Apache thing, that we don't have to rebuild the application all the time. So we can just code our JavaScript, and then when we reload the Magnolia the website, we just get the latest version of all the stuff we built. So we don't you don't have to do a deployment or a build every time you change something on your local environment, because otherwise it would be impossible for us to develop anything. It would take hours to just recompile everything all the time. In the build process, we run the RequireJS optimizer, which is a tool from RequireJS that combines all the files. It looks up all the dependencies in the various files, and then combines most of the JavaScript to a single file. Of course, you have to be careful in using RequireJS. You can do nested require calls and even variable require calls. And the downside of this is that the optimizer can't handle these things. So if you do that, it kind of breaks the optimizer, and you don't get the result. You get far more files than you would actually want. So we try to keep it as compact as possible. I think there's still some something to win there. We have to do more work in that, because I still think we have to do too many requests still. And there's the RequireJS, which we run over it to concatenate everything to hopefully make it as compact as possible. It's not like we're hiding our code from anyone, but just to minimize the requests. There are some downsides. RequireJS, you have to really choose to start using Require and not start using other loaders, because they will conflict each other, and I don't think that you'll have the full benefits of it when you set it up in an environment with other tools. Well, if you don't run the optimizer, or it doesn't run well, you get a lot of requests. It's a good thing that we make compact modules with compact with their own concerns, but that also, the result of that is there are many JavaScript files, so we have to tweak the optimizer a little more to increase the amount of JavaScript requests. And it can be hard to get all the paths right. So everything is there's no absolute URLs through the JavaScript, and it can be a hassle to, especially if you have a complex setup, to get everything right, to make sure that the right scripts are loaded and the right versions and everything. But well, in the end, we got it to work. And I wouldn't recommend this for smaller projects. It's a bit of an overkill. I don't know what the exact term is, but I don't think you can benefit from it in a small project. But the situation we have with many different websites and a lot of functionality inside the JavaScript, I think it really helped us a lot. So it also changed the way we code. Of course, we didn't do a lot in the global space, but also by namespacing, it was clogged, it was messy, you didn't know where things were coming from. We were just growing, the amount of JavaScript was just growing too fast to keep it under control. So, and this helped us to make compact modules, and it really changed the way we think about the coding. And of course, it hopefully prevents you from repeating yourself all the time. And it actually made our code much more reusable. We are forced to make the code, it has to run on its own. So you have to be able to use it throughout all the websites, and that's a mindset we adopted, and we are still improving. And what is really nice, we can do independent site upgrades. So because of the versioning, we don't have to check all websites. If we add some JavaScript functionality, we can rest assured that a lot of the older websites are still functioning, and we don't break anything by adding new features or changing APIs or stuff like that. Of course, you still have to be careful with this, but it goes quite well. And what we're still working on is that we want to build this quality control in the build process. We started using QUnit for some of the modules. It's a unit testing platform framework. We just started it, so I think we need some more time to find out how we can implement it in our process. And I believe it's also in the Maven build process you can set it up so it runs on every check-in or every build, or in Jenkins as well. I think that every time you check in the code, it runs the test, and yeah. So we're still working on that one to have more test coverage on the front end.
I'm just curious, how do you go about keeping track of what sites are using which version? Do you have a mechanism for? Is it easy to tell which one is using or not?
Unfortunately, not. No. Well, we can. You can always open Firebug and check for a specific website you can find out, but there's no like one big scheme of all the dependencies.
Is it maybe does it change it doesn't change any of the file names or append a query string or anything like that?
No.
No. Okay.
No. Just in the path. Like my colleague said, the version is part of the path to the JavaScript file.
Okay. And do you think this is valuable mostly for sites that use multiple sites, or would it be useful for just if you're running one big website?
It could be, but then I think if you run one big website and you make really specific stuff for a certain section of the website, right, maybe like that, but to us it's important that we can reuse our stuff. That's the main thing. Well, that concludes my talk. Thank you.